The Soviet Union's 30-year obsession with Venus reveals a story of ambition, failure, and unexpected discovery. Between 1961 and 1984, Soviet Venera missions braved scorching heat, crushing pressure, and toxic clouds to study Earth's mysterious twin. Despite harsh conditions that melted lead, these probes did more than survive. They captured the first images from another planet's surface and sent back vital atmospheric data. But what did they really find? Was there life, or was it all a mistake? Today, we dive into the Soviet Venus missions and unravel their incredible legacy. The first attempts. The Soviet space program turned to Venus when Mars seemed too difficult to reach consistently. February 12, 1961 marked the launch of Venera 1, the first Soviet attempt to probe our neighboring planet. The spacecraft lost telemetry just 7 days after launch and drifted silently toward Venus, never transmitting data upon arrival. Venera 2, launched in November 1965, suffered a similar fate when its communication systems failed after leaving Earth orbit. But the Soviets refused to give up. Venera 3, launched on November 16, 1965, became the first human-made object to impact Venus on March 1, 1966, though it crashed without sending back any information. The breakthrough came with Venera 4 in June 1967, which successfully entered Venus's atmosphere and transmitted the first chemical analysis back to Earth. The probe revealed a dense hostile atmosphere composed of 90 to 95% carbon dioxide with crushing pressure and searing temperatures. Despite failing to reach the surface intact, Venera 4 proved that spacecraft could survive entry into another planet's atmosphere and paved the way for future missions to probe Venus's sulfuric acid clouds and scorching surface. First surface success, Venera 7, launched in August 1970, achieved what many thought impossible: the first successful soft landing on another planet's surface. The probe endured surface temperatures exceeding 465 degrees Celsius and atmospheric pressure 90 times greater than Earth's. For 23 precious minutes, Venera 7 transmitted data from Venus's hellish surface, providing the first direct measurements of conditions on another world. The mission was led by Soviet engineer Georgy Babakin, who had designed the spacecraft to be massively overbuilt to ensure survival. The probe's parachute partially failed during descent, causing it to topple over upon landing, but its robust construction allowed it to continue operating despite the mishap. This groundbreaking achievement proved that spacecraft could not only survive Venus's extreme environment, but also function long enough to send valuable scientific data back to Earth. The temperature and pressure readings confirmed what earlier atmospheric probes had suggested. Venus was a world of extremes where nothing resembling Earth life could possibly survive. Yet the successful landing opened the door for more ambitious missions that would soon reveal surprising discoveries about our planetary neighbor. First images from hell. October 1975 marked a historic breakthrough when Venera 9 and Venera 10 became the first spacecraft to successfully transmit images from another planet's surface. Venera 9 landed on October 22, 1975, followed by Venera 10 3 days later. The black and white photographs revealed a rocky, barren landscape covered in volcanic basalt formations and scattered angular boulders. The images contradicted earlier assumptions of a uniformly smooth, dust-covered surface, instead showing a world with surprising geological diversity. Each lander carried a suite of instruments designed by Soviet scientist Mikhail Marov that detected sulfur compounds and evidence of ongoing volcanic activity, suggesting Venus remained geologically active. The harsh atmosphere posed immense engineering challenges, but both probes exceeded expectations by operating for 53 minutes and 65 minutes respectively, far longer than their designed 30-minute lifespans. The images showed flat bedrock surfaces with loose regolith and revealed that despite the crushing atmosphere, substantial amounts of sunlight reached the surface. These missions fundamentally changed our understanding of Venus from a mysterious cloud-shrouded world to a dynamic volcanic planet with complex surface features that continue to intrigue planetary scientists today. Color and chemistry. The 1982 launches of Venera 13 and Venera 14 really represented the pinnacle of Soviet Venus exploration technology. For the very first time in history, color images were transmitted from another planet's surface, revealing this orange-brown terrain bathed in the eerie glow of Venus's thick atmosphere. Venera 13 operated for a record-breaking 127 minutes on March 1, 1982, while Venera 14 functioned for 57 minutes on March 5, 1982. These missions were overseen by Soviet planetary scientist Roald Sagdiv, who later became director of the Space Research Institute. Chemical analysis revealed surface compositions similar to Earth's basalt, but with some intriguing differences. Both landers detected evidence of layered rocks and possible erosion patterns that seemed impossible without liquid water. Yet Venus had been bone dry for billions of years. The X-ray fluorescent spectrometers found concentrations of potassium, uranium, and thorium in ratios similar to volcanic rocks on Earth, suggesting Venus had undergone planetary differentiation just like our own world. These discoveries sparked intense debates about Venus's geological past and raised puzzling questions about how sedimentary-like features could form in such an arid, hostile environment. The missions really deepened the paradox of how Venus transformed from a potentially Earth-like world into a scorching wasteland. Balloons in the clouds. December 1984 brought the most ambitious Soviet Venus missions yet, Vega 1 and Vega 2, which combined atmospheric balloons with surface landers in an unprecedented dual approach. The balloon components, developed under the leadership of Soviet engineer Vyacheslav Lincoln, were designed to float at about 53 to 54 kilometers altitude in Venus's middle atmosphere for extended periods. Vega 1's balloon operated for 46 hours, while Vega 2's functioned for 60 hours, drifting approximately 11,600 kilometers and 11,100 kilometers respectively through Venus's turbulent skies. The balloons revealed Venus's atmospheric dynamics to be far more complex than simple greenhouse heating models had predicted. They detected violent wind turbulence, sudden downdrafts of 1 to 3 kilometers, and unexpected convection patterns that really challenged existing theories about planetary atmospheres. Meanwhile, the lander components analyzed surface composition using gamma-ray spectrometers, and discovered that Venus's lower cloud layers likely contained phosphoric acid, rather than just sulfuric acid. The atmospheric data showed that Venus's climate system involved intricate interactions between surface heating, cloud formation, and global wind patterns. These Vega missions pushed the frontiers of planetary meteorology and atmospheric chemistry, providing insights that continue to influence climate models for both Venus and Earth today. The life controversy. In 2012, Russian scientist Leonid Sanfomality from the Space Research Institute made headlines by claiming he had discovered signs of life in 30-year-old photographs from Venera 13. Sanfomality analyzed the images using modern digital enhancement techniques and identified several objects that appeared to move between photographs taken just minutes apart. He suggested these moving objects, which he dubbed Disk, Black Flap, and Scorpion, might represent primitive life forms adapted to Venus's extreme environment. The scientific community, though, reacted with intense skepticism. NASA astrobiologist David Grinspoon and other planetary scientists quickly pointed out that the apparent movement could easily be explained by image processing artifacts, shifting debris, or maybe even mechanical parts from the lander itself falling into view. The surface temperature of 462 degrees Celsius and crushing atmospheric pressure make it virtually impossible for any known form of life to survive. Some Russian Venera probes had indeed detected particles in Venus's lower atmosphere about 1 micron in length, roughly the size of bacteria, but these were most likely dust particles or atmospheric aerosols rather than biological organisms. While the controversy generated significant media attention, the scientific consensus remains that Venus's surface conditions are far too extreme to support any form of life as we understand it. Scientific legacy. The Soviet Venera program, achieved an unprecedented string of planetary exploration firsts that fundamentally transformed our understanding of Venus. Venera 3 became the first human-made object to reach another planet's surface. Venera 4 performed the first atmospheric analysis of another world. Venera 7 achieved the first successful planetary soft landing, and Venera 9 transmitted the first images from another planet's surface. Between 1961 and 1984, the Soviets launched 28 Venus missions, with 13 successfully entering the planet's atmosphere and 10 reaching the surface. The program's success rate honestly improved dramatically over time, with later missions like Venera 13 and the Vega probes operating far beyond their design specifications. The data collected revealed Venus as a world of extremes: surface temperatures hot enough to melt lead, atmospheric pressure equivalent to being 900 meters underwater on Earth, and clouds of concentrated sulfuric acid. These discoveries showed that despite Venus's similar size and mass to Earth, the two planets had evolved along completely different paths. The Venera missions demonstrated that robotic exploration could achieve remarkable scientific discoveries at a fraction of the cost of human missions, establishing templates for planetary exploration that continue to influence mission design today. The Soviet achievement to this day remains unmatched. No other nation has successfully landed on Venus since 1984. The search for ancient oceans. Recent analysis of Venera and Vega data has, really renewed scientific interest in Venus's mysterious past. The atmospheric measurements revealed deuterium to hydrogen ratios, suggesting Venus once possessed substantial water oceans that gradually escaped to space over billions of years. Venera 12 detected lightning activity in 1978, indicating ongoing atmospheric dynamics that might preserve clues about the planet's watery past. The surface composition data from multiple landers showed evidence of granite-like rocks that on Earth typically form through water-mediated processes, raising some pretty intriguing questions about Venus's geological history. Soviet atmospheric chemist Mikhail Zolotov later proposed that Venus might have remained habitable for up to 2 billion years after formation, potentially long enough for life to evolve before the runaway greenhouse effect took hold. The phosphine detected in Venus's upper atmosphere by Earth-based telescopes in 2020 has reignited debates about possible microbial life surviving in the planet's clouds, though this remains highly speculative. While the Venera missions found no direct evidence of life, their comprehensive atmospheric and surface data continue providing crucial insights into planetary evolution and the conditions necessary for life to emerge and survive in extreme environments. Engineering marvels. The engineering challenges overcome by Venera spacecraft represented, honestly, some of the most impressive technological achievements of the Cold War space race. Each lander had to survive a journey of over 100 million kilometers through space, then endure entry into an atmosphere 90 times denser than Earth's, all while maintaining structural integrity under crushing pressure and corrosive conditions. Soviet engineer Georgy Babakin's design team developed specialized materials and cooling systems that could function in temperatures exceeding 450 degrees Celsius. The landers used titanium pressure vessels and thermal insulation systems that pre-cooled the internal electronics before landing. Venera 13 and 14 employed spring-loaded mechanisms to eject protective lens caps and deploy soil sampling arms in the hostile environment. The Vega balloons represented even greater engineering complexity, requiring altitude-controlled floating platforms that could survive sulfuric acid clouds while maintaining radio contact across interplanetary distances. Communication systems had to penetrate Venus's dense atmosphere and transmit across millions of kilometers back to Earth, using only limited battery power. The success of these missions demonstrated Soviet technological superiority in planetary exploration during the 1970s and 80s, achieving engineering feats that remain impressive by today's standards and inspiring current Venus mission concepts being developed by NASA and other space agencies. Modern revelations. Contemporary analysis of Venera data using modern computational techniques, continues revealing new insights about Venus's evolution and its potential for past habitability. Computer models based on atmospheric measurements from Venera 11, 12, and the Vega probes suggest Venus might have maintained liquid water oceans until as recently as 715 million years ago, much later than previously thought. The surface composition data collected by multiple landers indicates Venus underwent extensive volcanic resurfacing within the past 500 million years, potentially erasing evidence of earlier, more temperate conditions. Recent studies of the phosphine signatures detected in Venus's atmosphere have prompted renewed examination of Venera atmospheric data, though no definitive biosignatures have been identified. NASA's planned Veritas and Da Vinci Plus missions will build directly on Soviet discoveries, using advanced spectrometers and imaging systems to investigate the tantalizing clues left by the Venera program. The Soviet Venus missions established that, while the planet's surface remains utterly hostile to life as we know it, its atmospheric chemistry and geological history contain important secrets about planetary evolution. These missions proved that systematic robotic exploration could unlock the mysteries of even the most forbidding worlds, setting the stage for future discoveries that may finally answer whether Venus ever harbored life. The Soviet Venera and Vega missions transformed our understanding of Venus from a mysterious, shrouded world to a dynamic volcanic planet with a complex atmospheric system. They achieved humanity's first images and chemical analysis from another planet's surface, establishing crucial foundations for all subsequent planetary exploration. Though no definitive signs of life were discovered, these pioneering missions revealed a world with a rich geological history and atmospheric complexity that continues to intrigue scientists today. Subscribe to Stellar Tech for more deep dives into space exploration's greatest achievements, where scientific truth meets human curiosity and, discovery awaits. Somewhere in the frozen archives of Moscow lies evidence of humanity's most forgotten triumph, a successful Mars landing that happened decades before the world knew about it. Between 1960 and 1971, the Soviet Union launched a series of top-secret missions to Mars that were systematically erased from history books. While NASA celebrated its moon landings, the Soviets were quietly attempting something far more ambitious, reaching the red planet first. Mars 3 didn't just reach the Martian surface, it made the first successful soft landing in human history. Today, we're uncovering the declassified truth about the Soviet Mars program that the world was never meant to know about.
The shadow launches.
October 1960 marked humanity's first attempt to leave Earth's gravitational influence and reach another planet. Mars, 1960. A lifted off from Baikonur Cosmodrome aboard a modified R-7 ICBM, but within seconds the rocket veered off course and self-destructed. 4 days later, Mars 1960B suffered the same fate-reaching orbit but never escaping Earth's pull before burning up in the atmosphere. These weren't just technical failures, they were national embarrassments that the Soviet space program couldn't afford to acknowledge. Sergei Korolev, the chief designer of the Soviet space program, had promised Premier Khrushchev a Mars victory to match their successes with Sputnik and Yuri Gagarin. Instead, both missions were quietly reclassified as Cosmos satellites, a catch-all designation used to hide failed interplanetary attempts. Western intelligence agencies only learned about these missions decades later through declassified documents. The Soviet strategy was clear. If they couldn't succeed publicly, they would fail in complete secrecy. The engineers' work was a race against time, battling both the remoteness of space and the limitations of old technology. The successful restoration gave hope not only to the mission but also to
Mars 1, the lonely pioneer.
November 1962 brought the Soviet Union's first partial success with Mars 1, a probe that actually escaped Earth's gravity and began the long journey to the Red Planet. Launched during a narrow 26-month launch window, the spacecraft represented a technological leap forward, equipped with a magnetometer, cosmic dust detectors, and instruments designed to search for water vapor in the Martian atmosphere. For 124 million miles, Mars 1 transmitted data back to Earth, proving that interplanetary communication was possible. The spacecraft sent 61 successful transmissions before disaster struck on March 21, 1963. As Mars grew larger in the probe sensors, all contact was lost. Engineers at the Soviet Deep Space Network in Yevpatoria, Crimea waited desperately for signals, but Mars 1 had gone silent forever. The most likely cause was a leak in the attitude control gas tanks, which left the spacecraft spinning helplessly with its antenna pointing away from Earth. Despite the communication failure, Mars 1 proved the Soviets could reach interplanetary space, a crucial psychological victory that fueled their determination to continue.
The explosive disasters.
March 1969 witnessed one of the most spectacular failures in space exploration history. Mars, 1969. A sat atop a massive Proton K rocket at Baikonur, carrying the most advanced Mars probe ever built, a bus-sized spacecraft designed to orbit the planet and deploy a surface lander. The countdown proceeded normally until T+0 seconds, when the 2.4 million-pound thrust rocket erupted into a fireball visible for miles. The explosion shattered windows in nearby villages and sent burning debris across the Kazakh steppes. 5 days later, Mars 1969B met an equally violent end when the upper stage failed during separation, sending the multi-million-dollar payload tumbling back to Earth. These catastrophic failures represented more than technical setbacks. They were existential crises for the Soviet space program. Vasily Mishin, who had taken over from Korolev after his death in 1966, faced intense pressure from the Politburo to deliver results. The twin explosions cost the USSR 2 years of preparation and millions of rubles, but more importantly, they handed NASA a clear advantage in the race to Mars.
Zond 2's silent journey.
Zond 2's silent journey. So, late in 1964 marked another Soviet attempt with Zond 2, a spacecraft that really represented the cutting edge of interplanetary technology. This mission carried experimental plasma thrusters, revolutionary ion propulsion systems that honestly had never been tested in deep space, along with an infrared spectrometer designed to detect vegetation on Mars. For 6 months, Zond 2 flew silently through the void, its experimental systems functioning perfectly as it approached the red planet. The spacecraft's trajectory was nearly perfect, aiming for a close flyby that would provide detailed images of the Martian surface. Controllers at the Soviet Mission Control Center in Kaliningrad maintained regular contact until suddenly, all transmissions just ceased. The probe missed Mars by approximately 1,000 miles, agonizingly close to success. Post-mission analysis suggested either a power system failure or a thermal control malfunction had crippled the spacecraft. Zond 2 joined the growing cemetery of Soviet hardware drifting in interplanetary space, another ghost probe carrying humanity's dreams but unable to fulfill them. Each failure taught valuable lessons, but the Soviets were running out of time and patience.
The M69 catastrophe.
The M69 catastrophe. 1969 was supposed to be the year the Soviet Union finally conquered Mars. After years of failures, Soviet engineers had designed the M69 series, massive, sophisticated spacecraft that would not only orbit Mars but also deploy landers to study the surface. Mars 1969, A, and Mars 1969. B represented the pinnacle of Soviet space technology, each weighing several tons and packed with advanced instruments. The missions were so secret that even their existence was classified until decades later. When both missions exploded during launch within 5 days of each other, it created a crisis at the highest levels of Soviet leadership. Dmitry Ustinov, the defense minister overseeing space programs, personally intervened to prevent news of the disasters from reaching the public. The explosions were so violent they actually registered on seismic equipment, but official records listed them as routine Cosmos missions. These failures cost the Soviet Union more than money and prestige. They cost crucial time.
Mars 2, first impact.
November 27, 1971 became a historic date that, honestly, few people remember. Mars 2, the first component of the Soviet Union's most ambitious Mars mission, screamed through the Martian atmosphere at over 13,000 miles per hour. The lander was equipped with a parachute system, retro rockets, and even a small Prop-M rover designed to waddle across the surface on metal skis while tethered to the main lander. Everything that could go wrong did go wrong. The parachute system failed to deploy properly, the retro rockets never fired, and the lander slammed into the Martian surface with the force of a meteorite. There was no signal, no data transmission, just silence from the red planet. However, Mars 2 had achieved something unprecedented. It became the first human-made object to physically reach the surface of Mars. The impact occurred in the Hellas Basin, creating a small crater that remains there today, an unmarked grave for Soviet ambitions. While Western media focused on the failure, Soviet engineers quietly celebrated a grim milestone. They had touched another world, even if it meant destroying their spacecraft in the process.
Mars 3's miraculous landing.
Mars 3's miraculous landing on December 2, 1971, honestly rewrote the history of space exploration in just 14.5 seconds. Mars 3's lander descended through a massive planet-wide dust storm that had been raging for weeks, but somehow, everything worked perfectly. The parachute deployed, the retro rockets fired right on schedule, and the spacecraft made a controlled soft landing on the Martian surface. The first successful soft landing on another planet in human history. Controllers at the Deep Space Communication Center in Crimea erupted in celebration as telemetry signals confirmed touchdown. For those precious seconds, humanity had a functioning robotic outpost on Mars, equipped with cameras, soil analysis equipment, and atmospheric sensors. The lander immediately began transmitting, sending back the first image ever captured from the surface of Mars. Then, as suddenly as it had begun working, Mars 3 fell silent forever. The transmission, yeah, it consisted mostly of gray static with some unclear features, but it represented humanity's first glimpse of Mars from ground level. The Prop M rover was never deployed because the lander died too quickly. Somewhere in the Martian dust, that tiny robot still waits, a monument to Soviet engineering that survived the journey but just couldn't survive the destination.
The cover-up campaign.
Soviet space failures disappeared into a bureaucratic black hole of secrecy that lasted for decades. When Mars missions exploded during launch, they were immediately reclassified as Cosmos missions, generic designations that suggested routine Earth satellite deployments. Vladimir Chelomey, one of the chief designers, created an entire system for burying embarrassing failures behind false documentation. Launch manifests were altered, mission reports were classified, and even the engineers involved were sworn to secrecy under threat of imprisonment. The KGB monitored space program personnel to prevent leaks about failed missions. This wasn't just about hiding technical problems. It was about maintaining the Soviet Union's image as a space superpower. While NASA failures were broadcast on live television for the world to see, Soviet disasters vanished completely from public record. Western intelligence agencies sometimes detected mysterious launches through radar tracking, but without official confirmation, these missions remained ghosts in the historical record. The secrecy was so complete that many Soviet citizens never learned about their country's Mars program until after the USSR collapsed in 1991. This systematic cover-up meant that Soviet achievements, like Mars 3's successful landing, were also hidden from history.
The lost robot.
Buried somewhere in the Martian regolith lies Prop M, the Soviet Union's first Mars rover that never got to rove. This lunchbox-sized robot was designed to crawl away from the Mars 3 lander using metal skis, dragging a tether cable behind it to maintain communication. The rover carried a penetrometer to test soil density and 2 contact sensors to detect obstacles. Prop M was designed to operate for months, slowly mapping the immediate landing area and sending back detailed surface analysis. The rover represented groundbreaking engineering. It had no wheels because Soviet engineers worried they would clog with Martian dust. Instead, the robot was designed to slide forward on twin skis while explosive bolts periodically advanced the device in small hops. When Mars 3 died after 14.5 seconds, Prop M never received the deployment signal. The rover remains locked inside the lander, perfectly preserved by Mars's thin atmosphere and extreme cold. NASA's orbital reconnaissance has never located the Mars 3 landing site, meaning Prop M could remain lost forever. This tiny robot represents humanity's first attempt at mobile Mars exploration, a precursor to Sojourner, Spirit, Opportunity, and Perseverance that came decades later.
Hidden history revealed.
The full scope of Soviet Mars ambitions only became clear after 1991, when classified archives began opening to researchers. Documents revealed at least 18 secret Mars missions between 1960 and 1973, with many more attempts that remain classified. The Mars 3 success was deliberately downplayed even in internal Soviet documents because the 14.5-second transmission time seemed embarrassing compared to ongoing Apollo achievements. Roald Sagdiv, former director of the Soviet Space Research Institute, later admitted that political pressure forced engineers to attempt impossible deadlines with inadequate testing. Each mission failure cost millions of rubles and years of preparation, but the secrecy meant these lessons couldn't be shared with the international scientific community. The Soviet Mars program represented one of history's most ambitious scientific endeavors, combining cutting-edge technology with Cold War desperation. Mars 3's achievement, the first successful soft landing on Mars, remained largely unknown until decades after it happened. Today, as NASA and SpaceX plan human missions to Mars, they're building on foundations laid by Soviet engineers who dared to reach for another world in complete secrecy. The Red Planet conquered the Soviets, but not before they conquered it first. The Soviet Union reached Mars first, landed successfully, and sent back humanity's first surface image. But almost nobody knew about it. Mars 3's 14.5-second transmission represents one of history's most underappreciated achievements, buried by Cold War secrecy and overshadowed by moon landings. These declassified missions prove that space exploration's greatest victories sometimes happen in complete silence. The race to Mars wasn't won by the loudest publicity, it was won by engineers who dared to fail in secret until they finally succeeded. Subscribe to Stellar Tech for more hidden space history that rewrites everything you thought you knew about the cosmos. Right now, 15 billion miles from Earth, humanity's most distant messenger is revealing secrets that are, honestly, rewriting our understanding of space. Voyager 1 crossed into interstellar space back in 2012, becoming the first human-made object to leave our solar system's protective bubble. But after a terrifying communication blackout in 2023, the spacecraft came back online with data that absolutely stunned scientists. The space between stars isn't the empty void we imagined. It's actually a dynamic, structured environment filled with cosmic weather, invisible boundaries, and phenomena that challenge everything we thought we knew about our galaxy.
The silent crisis.
April 2024 brought relief after months of cosmic terror. Voyager 1 had gone completely silent, transmitting only garbled signals that made no sense to NASA engineers at the Jet Propulsion Laboratory. After 46 years of faithful service, humanity's most distant explorer was dying. The culprit was a corrupted memory chip, likely damaged by a cosmic ray strike. The very phenomenon Voyager was studying had wounded it. Engineers faced an unprecedented challenge, performing brain surgery on a spacecraft using 1970s technology from 15 billion miles away, where radio signals take over 22 hours for a round trip. The rescue operation required rerouting code into backup memory areas, essentially giving CPR to a robot that predated most modern computers. By May 2024, the patient showed signs of life, with all 4 science instruments gradually coming back online. This wasn't just an engineering triumph, it was humanity's lifeline to the only measurements we have from beyond our solar system.
Magnetic mysteries beyond the edge.
The first shock came from Voyager's magnetometer readings after crossing the heliopause. Scientists expected some differences, but the interstellar magnetic field showed a dramatic misalignment compared to our sun's magnetic influence. This wasn't a gradual transition, it was a sharp boundary suggesting something far more significant than anyone had anticipated. The readings point to Voyager 1 entering a magnetic turbulence zone where galactic magnetic fields twist and reconnect in ways that could, honestly, reshape our understanding of galactic structure. These aren't small ripples in space, they're fundamental forces operating on scales larger than our entire solar system. The magnetic field orientations Voyager measures might even channel cosmic material into denser regions, potentially influencing where new stars form in our region of the galaxy. Each measurement reveals that interstellar space has its own magnetic weather patterns, invisible highways of force that guide particles across vast cosmic distances. The spacecraft continues to detect these magnetic anomalies, proving that the space between stars is far more structured and dynamic than anyone predicted.
The cosmic ray avalanche.
Crossing into interstellar space triggered an immediate and honestly shocking discovery. Voyager's cosmic ray detector recorded a sharp spike in high-energy particles accelerated to nearly light speed by distant supernovae and black holes. The increase wasn't gradual, it was abrupt, like stepping through an invisible barrier. This revelation exposed how effectively our sun's heliosphere shields Earth from the harsh radiation environment of interstellar space. We're living in a cosmic oasis, protected from particle bombardment that would be lethal to unshielded life. But the pattern isn't uniform. Voyager has detected systematic variations, suggesting natural radiation corridors, cosmic highways where particles preferentially flow. These measurements hint at larger galactic structures, possibly ancient scars left by stellar explosions that shaped our neighborhood millions of years ago. The spacecraft may be detecting pressure gradients that map onto invisible architecture spanning light years. Each cosmic ray measurement reveals more about the galactic environment, showing that we're not just measuring local conditions, but glimpsing the aftermath of cataclysmic events that continue to influence our cosmic neighborhood today.
Whispers in the void.
You know, the silence of space doesn't actually exist. Voyager's plasma wave instrument has completely shattered the old myth of cosmic emptiness by detecting these constant low-frequency oscillations that just permeate interstellar space. And these aren't just random fluctuations, no, they're structured signals, suggesting that the space between stars has its own unique acoustic signature. The instrument has even picked up multiple plasma density spikes, kind of like pressure waves moving through an invisible medium out there. Scientists think these could be shock fronts left behind by ancient supernovae that exploded thousands of years ago, still rippling through the interstellar medium today. So Voyager isn't just drifting through emptiness, it's flying through an invisible fog with its own distinct layers and properties. Some regions are hotter, others are denser, and together they create this complex three-dimensional structure that actually resembles weather patterns a lot more than the uniform void scientists once expected. This cosmic hum, it's really the background activity of our galaxy, a constant whisper from the space between stars. The plasma waves are revealing that interstellar space has its own dynamics, its own currents and temperatures, creating an environment that's far more active than anyone could have imagined.
Interstellar weather patterns.
Voyager 1 has actually passed through at least 2 distinct interstellar cloudlets since crossing the boundary, and this has revealed that the space between stars has structure, kind of like an ocean with currents and eddies. These aren't visible clouds though, they're regions where the plasma, dust, and gas density suddenly changes by factors of 2 or even 3 times. The spacecraft's instruments show evidence of these structured plasma ripples with clear boundaries, almost like atmospheric fronts out in space. NASA scientists now believe our sun is moving through the local interstellar cloud, and Voyager is helping to define its outer edges right now. This cloud exists inside the much larger local bubble, which is this enormous cavity created by ancient supernovae. These density shifts, they actually affect Earth's cosmic ray exposure over millennia. As our solar system drifts through different interstellar environments at 450,000 miles per hour, the radiation environment at Earth subtly changes, and that can potentially affect cloud formation and even mutation rates in living organisms. Voyager is showing us that interstellar space isn't just a straight path, it's really a gauntlet of invisible forces that create this complex, ever-changing cosmic landscape, complete with its own weather systems and boundaries.
Digital resurrection.
So, the 2023 communication crisis nearly ended humanity's only direct window into interstellar space. For months, Voyager 1 was transmitting incomprehensible data, its memory corrupted by cosmic ray bombardment. NASA engineers were suddenly facing one of their greatest challenges: remotely repairing a spacecraft that's actually older than most of their careers, and doing it with technology from the Carter administration no less. The solution took unprecedented ingenuity, rerouting decades-old code into backup memory areas while somehow maintaining all the critical functions across a 15 billion-mile gap. And every command took 22 hours to reach the spacecraft, so real-time troubleshooting was just impossible. The team basically performed remote surgery on a patient they couldn't see or touch. In April 2024, they finally had a breakthrough when basic telemetry resumed, and that was followed by the gradual revival of the scientific instruments. By June 2024, all 4 active science instruments were functioning again. This wasn't just an engineering triumph, it was humanity's lifeline to the only measurements we have from beyond our solar system's protective bubble. The rescue operation showed that even 1970s technology could be revived through innovative engineering, buying us precious additional years of interstellar data collection.
Mapping the invisible galaxy.
Voyager 1 is creating something, well, truly unprecedented, a navigational chart of interstellar space. With every data packet sent back, scientists are able to construct 3-dimensional models of the Milky Way's magnetic and radiation zones, using Voyager's measurements as crucial anchor points. This, honestly, represents the first real-scale cartography of our stellar neighborhood. It's a bit like having a weather satellite, but for the cosmos. The cosmic ray gradients, particle density readings, and magnetic field orientations are revealing natural shields and danger zones, and these could really determine whether humans can safely venture beyond our solar system. The radiation environment that Voyager measures is far more intense than what astronauts face in Earth orbit, which makes these maps absolutely crucial for any future interstellar missions. Some astrophysicists even believe the structures Voyager is mapping may influence star formation patterns across our galactic region. Quietly, the spacecraft is drawing the first blueprint of the space between stars, creating detailed models that get refined with every new measurement. This mapping project has, well, become the foundation for understanding how to navigate the void between stars, potentially guiding future spacecraft through the safest corridors of interstellar space.
The protected oasis.
Voyager's measurements have revealed a profound truth about Earth's place in the cosmos. Our solar system exists within a protective bubble that shields us from an environment far more hostile than anyone realized. The dramatic increase in cosmic radiation beyond the heliopause demonstrates how effectively the sun's magnetic field deflects dangerous particles that would otherwise bombard our planet. This discovery reframes Earth not just as our home, but as our shelter in a cosmic storm. The interstellar medium contains radiation levels that would pose serious threats to unprotected life, making our heliosphere a crucial barrier against galactic hazards. Voyager's data shows that this protection varies as our solar system moves through different interstellar environments over millions of years. The spacecraft's measurements of density variations and magnetic field changes suggest our cosmic neighborhood is far from uniform. We're traveling through a complex landscape of radiation zones, magnetic boundaries, and plasma clouds that create an ever-changing environment around our solar system. Understanding these variations helps explain long-term climate patterns and cosmic ray exposure cycles that may have influenced life's evolution on Earth.
The Eternal Journey.
Beyond its scientific mission, Voyager 1 carries humanity's most enduring message to the cosmos. The golden record attached to the spacecraft contains sounds, music, greetings in 55 languages, and 116 images representing Earth's diversity. This time capsule is engineered for extreme longevity, designed to survive over 1 billion years in the harsh environment of space. In approximately 40,000 years, Voyager 1 will make its closest approach to the star Gliese 445, passing within 1.6 light-years of this distant red dwarf. Long after Earth's continents have shifted beyond recognition, long after human civilization has evolved or disappeared, this record will endure. Voyager represents humanity's most lasting trace in the universe, an ambassador that will outlive our species. No other human object will leave the heliosphere for decades, making Voyager literally our longest-lasting monument. The spacecraft transforms from a scientific probe into something more profound, a message frozen in time, carrying the essence of who we were in 1977 across the galaxy for eons to come. This cosmic time capsule gives Voyager significance that transcends its scientific achievements, becoming humanity's first tentative step into eternity.
Redefining reality.
The space beyond our solar system isn't the featureless void astronomers once imagined. Voyager 1 has revealed a dynamic structured environment with weather patterns, magnetic topography, and radiation zones that shape our galaxy's invisible architecture. The transition from our solar bubble to interstellar space isn't clean. It's messy, complex, and honestly pretty fascinating. Magnetic fields don't align as expected, radiation environments change dramatically, and plasma waves suggest constant activity we never knew existed. Voyager's discoveries prove that interstellar space has layers, fronts, and boundaries, creating a textured cosmic landscape far more intricate than anyone predicted. The spacecraft continues operating on borrowed time, with NASA making difficult decisions about which instruments to shut down as power gradually fades. Early 2025 saw the cosmic ray detector powered down to extend the overall mission, but 3 science instruments continue transmitting their faint 23-watt signals across the cosmic void. Each day Voyager 1 operates as a gift of knowledge from humanity's only direct sampling of the space between stars, rewriting textbooks with every transmission from the interstellar frontier. Voyager 1 reached the other side, and the reality is more extraordinary than fiction. The interstellar medium isn't empty. It's a structured, dynamic environment that challenges our understanding of cosmic architecture. From magnetic mysteries to plasma whispers, from radiation avalanches to cosmic weather patterns, Voyager continues revealing secrets that rewrite astronomy textbooks. This incredible journey proves that sometimes the most profound discoveries come from the simplest act of reaching beyond our boundaries. If you love real space exploration without the hype, smash that like button and subscribe to Stellar Tech for more mind-blowing cosmic discoveries. The universe is far stranger than we thought.